Chapter 4. In this chapter, we are going to talk about alkanes and cycloalkanes and their conformations, or basically their different forms in 3D space. In this specific video, I'm going to talk about general nomenclature for organic molecules, which is very important in PCAT or MCAT exams. And in the following videos, we are going to study the conformational analysis for acyclic molecules. Previously, we talked about hydrocarbons. Hydrocarbons are molecules that are composed of hydrogens and carbons. These hydrocarbons can have pi bonds in their structures, such as ethylene, as an example of an alkene, acetylene, example of an alkyne, and benzene ring, we call them unsaturated hydrocarbons. Now, if they lack the pi bond in their structure, such as ethane here, as an example for an alkane, we call them saturated hydrocarbons. In this chapter, chapter 4, we are specifically looking at these saturated molecules, alkanes and cycloalkanes. As you noticed in their name, they get the suffix "ane" at the end, so we don't confuse them with alkene and alkyne molecule. You can see the example for alkanes here, propane and butane. And for the cyclic ones, cycloalkanes, such as cyclopropane and cyclohexane. As you may notice, based on the different number of carbons, they get different prefixes. For example, for 3 carbon, we have the prefix prop, and for 4 carbon, we use the prefix but. So how do we determine what prefix to use here? Let's start with nomenclature of organic molecules. There is an IUPAC union that created a set of rules for naming organic molecules. And based on their system, the very first step is to identify the parent chain. So parent chain can either be linear or cyclic in organic molecules. And to name the parent chain, the first step is to find the number of carbons in the structure. For example, in this linear structure, I have 5 carbons attached to one another. And then the next step is to find that number in the table 4.1 and find the appropriate prefix for that. So the prefix for 5 carbon is pent, and since this is an alkane, it gets the suffix "ane" at the end, so this is pentane. For the cyclic structure, we need to follow the same steps. So this is, just remember, each corner in the cyclic structure has a carbon and 2 hydrogens attached to it. So I have 5 carbons in this structure, therefore the prefix is again pent, follows by ane. However, because this molecule is in a cyclic format, I need to use prefix cyclo before the name to identify that. And we have another example. So we have 4 carbons in this cyclic molecule, therefore the name for that is, for number 4 gets the prefix but, so the name would be cyclobutane. So it is required that you know the prefixes for carbon 1 to 10, and this table is available in your textbook as well. I also found a mnemonic online. You can memorize basically these prefixes by memorizing this mnemonic. You can create your own mnemonic or some other ways. If you want to name any kind of organic molecules, you need to deal with these prefixes. So it is very necessary that you know their names. We can also have branched alkanes. Sometimes there are more than one chain to identify when you have branched alkanes. In this case, the parent chain is the chain with the highest number of carbons, or the longest chain. So if you look at this example here, I can count the number of carbons from here: 1, 2, 3, 4, 5. This is one root. I can count from here 1, 2, 3, 4. This is another root. Or I can count 1, 2, 3, 4, 5, 6. So I have 6 carbons. 6 is the highest number. Therefore, the last root gives me the parent chain. So I have 6 carbon here. If you look at the table, the prefix for that is hex for 6 carbon, follows by suffix ane. So this is hexane. Now look at this molecule here and identify the name of the parent chain. Take a look at this. There are multiple ways that you can number the carbons here. It can be this root, it can be this one, or this one. Now if you examine all of them, the longest root would be this root. That gives me 9 carbons. And if you look at the table, 9 is non, followed by ane. So the parent chain in this molecule is non-ane. Now what happens if you have 2 chains with equal length? So these 2 structures, they are the same compounds, but the parent chain is counted differently. And we have 7 carbons in both of them as a parent chain. But which one is preferred? So whatever path that gives you the most substituent is preferred. In this one, we have 3 groups attached to the parent chain. In the other one, we have 2 groups attached to the parent chain. So this one is preferred. And the reason behind that is because it is easier to name the smaller substituent comparing to the longer chain of carbon. So overall, we can say parent chain is the longest chain with the most substituents. So substituents are the groups connected to the parent chain. The most substituents connected to the chain. After identifying the parent chain, we need to identify the substituent. And substituents are the groups that are attached to the parent chain. We can have different types of substituent. For example, we can have alkyl substituent. If you look at this example, this structure, this longest chain is my parent chain, and all of these groups attached to the parent chain are substituent. For naming alkyl substituent, you need to use the same prefixes that you use for naming the alkane molecules. However, instead of ane at the end, you need to use the basically suffix il. So for example, the first substituent here has 1 carbon. You can find the name in a table, so it gets the prefix meth. However, instead of ane, we used il, so this is methyl. The next one has 3 carbons attached to the parent chain. We know 3 carbon is prop, so it is propyl. The next one has 2 carbons attached, therefore the name is ethyl. Sometimes we can have substituents other than alkyl groups. For example, we can have halogens as substituents, and if they are substituent, they get the suffix O. For example, we have fluoro, chloro, bromo, ido. We can also have OH as substituents. We call that hydroxy. We also have CN. This is carbon-nitrogen triple bond group. We call that cyano. We can even have NO2 group as a substituent. We call that nitro. So for example, there is example here. If I look at the carbon chain, my longest chain is this chain. So this is going to be my parent chain. It has 6 carbons in it. Therefore, this is hexane. And I have chlorine as a substituent. So this one is chlorohexane. So later on, we are going to learn about the numbering of the parent chain. So basically, the complete name for this compound is 3-chlorohexane. We are going to learn about the numbering later, so don't worry about that now. Sometimes the alkyl substituents can be a little bit complex and they have their own name. So for example, if 3-carbon alkyl group attached to the parent chain from its second carbon, we call that isopropyl. So this is 1, 2, 3, and it is attached from its second carbon. So you remember, if it was attached from the first carbon, we call that propyl. But when it is attached from the second carbon, we call that isopropyl. We can also have a 4-carbon chain, and if it is attached from one of the terminal carbon, we call that isobutyl. And if it is attached from the central carbon, we have 1, 2, 3, 4 carbon, so it is attached from the central one, we call that tertiary butyl or tert butyl. Or some people call that chicken finger or chicken foot. So we have an example here. Let's identify the parent chain first. So we can count through different pathways, but the longest chain would be this one. So which gives me 1, 2, 3, 4, 5, 6, 7 carbons. So it is heptane. And my substituent is the 3-carbon chain, which is attached from the second carbon. So this is isopropyl. Okay, and as I said, we are going to learn about the numbering. So this is 4-isopropyl heptane. After finding the substituent and naming them, we need to number the parent chain to show the location of those substituents. There are a few sets of rules that we need to follow while numbering the parent chain. The first rule says that if there is only one substituent attached to the parent chain, we need to number the parent chain in a way that the substituent has the lowest number possible. There is an example here. This chain is the longest chain, so it's going to be my parent chain, and this is the only substituent attached to the parent chain. So I have 2 ways to number the parent chain. I can number the parent chain from left to right in this order, or number that from right to left, which gives me this order. Now if you look at these 2 numbering patterns, in the first one, the substituent gets number 2, and in the second one, the substituent gets number 6. So according to this rule, the lowest number is the winner. So this is the correct way of numbering the parent chain. Sometimes the parent chain may get more than one substituent. In this situation, we number the parent chain in a way to give the first substituent the lowest number possible. So if you look at this molecule here, again, this is my parent chain. This is the longest chain possible in this structure. Now I can number this parent chain from left to right or right to left. So left to right gives me this numbering pattern, and right to left gives me this numbering pattern. Now, if you look at the first substituent in this structure right here, that gets number 2. So the first substituent gets number 2. Now, if you look at this molecule right here, the first substituent gets number 3. So this is number 3. Now, number 2 is lower than number 3, therefore this is the correct way of numbering. Sometimes you may get a tie for the first substituent, meaning that the first substituent in both patterns of numbering may get the same number. So in this case, we look at the second substituent and we expect that to get the lowest number possible. So again, this is my structure. This is the parent chain here. Now, 2 ways of numbering, from right to left and left to right. So if we look at this numbering pattern, the first substituent gets number 2 and the second one gets number 3. So the first one gets number 2 and second one number 3. Now in the other numbering pattern, the first one gets number 2 and the second one gets number 5. Number 2 and 5. So as you can see, we have a tie for the first substituent. Both of them gets number 2. Now, for the second substituent, this structure has number 3. This one gets number 5. 3 is smaller than 5, so this is the correct way of numbering. Sometimes the previous rule cannot break the tie. In this situation, we will assign the lowest number possible alphabetically. So here is the structure. It has 5 carbons. I can number from left to right and right to left. So in this numbering pattern, the first substituent gets number 1 and the second one gets number 5. In the other numbering pattern, the first substituent gets number 1 and the second one gets number 5. So similar, or basically same numbering. So we have a tie here. In this situation, we need to assign the lowest number alphabetically, meaning that I have bromo and chloro. So bromine starts with letter B, therefore bromo is preferred, so bromo should get the lowest number possible. And if we do that, this is going to be the correct way of numbering this structure. After naming the parent chain and numbering the parent chain, finding the location of substituents and naming them, you need to put their names and numbers before the name of the parent chain in the alphabetical order. Sometimes you may have multiple substituents that are identical. In these situations, we use a prefix such as di if you have 2 of them, tri for 3, tetra for 4, and etc. So there are 3 notes here. While alphabetizing the substituent, we need to ignore these prefixes such as di, tri, tetra. For example, if you have dimethyl, meaning that you have 2 methyls connected to the parent chain, you need to alphabetize that as if it starts with the letter M rather than D. Note number 2 says that for the substituents such as tert-butyl, we also need to ignore the prefix tert. So we need to alphabetize tert-butyl as if it starts with the letter B rather than T. Note 3 says that we cannot ignore the prefix iso, meaning that if you have isobutyl or isopropyl as a substituent, you need to alphabetize them as if they start with letter I, not B or P. Alright, so this is the summary of naming molecules. So the very first step is to identify the parent chain. The second one is to name the substituents, find the substituent and naming them. Then you need to number the parent chain and assign the number to each substituent. We had a set of rules for that. And then you need to arrange the substituent alphabetically. to finalize the name of the molecule. Now let's do a practice and use all of these rules to name this molecule. So the first step is to identify the parent chain, which is the longest chain possible in the structure. So I can start counting, for example, from this way, start counting this way or that one. So there are multiple routes that you can start counting the molecule. However, the longest chain possible with the highest number of carbon would be this route. So this is gonna be my parent chain. Now let's count the number of carbon in the parent chain. This is 1, 2, 3, 4, 5, 6, 7, 8. So the parent chain has 8 carbons. Therefore it is oct. And since this is an alkane, this is octane. Then the next step is to identify and name the substituent and also number the parent chain. So I'm going to combine these two steps together. So let's first identify the substituent. I have a methyl here, chlorine here. This is isopropyl and another methyl here. Then I need to number the parent chain. Based on the numbering rules, I need to number the parent chain in a way that the first substituent gets the lowest number possible. So if I start numbering through this route, the first substituent would get number 2. However, if I start numbering from this route, the first substituent would get number 3. Therefore, the best way of numbering would be from right to left. Then let's write the name and location of all the substituents. So I have 2 methyl, so I separate the number and the letter with a dash. So this is 2 methyl. Then I have chlorine on carbon 2 as well, so this is 2 dash chloro. It gets the suffix O because it's a substituent. Then on carbon 5, I have isopropyl attached. So this is isopropyl. And then on carbon 6, I have 6 methyl. All right. Now, I have 2 methyl substituent in this molecule, so what I can do, I can basically combine them together. So instead of writing 2 methyl, 6 methyl, I can write 2, comma, 6. So to separate the number, we use comma, dash. I have 2 methyls, therefore it should be dimethyl. Now let's put all the substituents basically before the name of the parent chain alphabetically. So for methyl substituent, I need to look at letter M. I ignored the di. For chloro, I look at the letter C. For isopropyl, I look at I. Therefore, the name would be, it's going to be 2 chloro dash, to separate each substituent we use a dash, 5 dash isopropyl dash 2 comma 6 dash dimethyl. The last substituent, we don't need to separate it from the parent chain, so we don't use a dash here, octane. Okay, so this is the appropriate name for this structure. Till now, we learned about nomenclature of alkane functional groups. Other functional groups are also named using the same procedure. We need to find the parent chain, number the parent chain, find the substituent, but we need to do some minor modifications. The very first thing, when you have multiple functional groups present in the molecule, is to first identify them and then arrange them in order of priority. And here is that order. So for example, if you have an alkene and a ketone in the molecule, if you want to name the parent chain, you need to use the suffix "on" because ketone is basically preferred over the alkene. So let's look at some examples to understand this concept better. Let's name these three molecules. So the first step is to identify the functional groups that are presented in the molecule. In the first structure, I can recognize alkane chain and also alkene. If I look at this table, alkene is preferred over alkane. Therefore, my parent chain should get the suffix "in" instead of "ane". After doing this, you need to follow all the instructions that we talked about for naming molecules. So the first step is to identify the parent chain, which is the longest chain possible in the structure. And in this specific structure, the longest chain would be this one. Okay. So let's count the number of carbons. 1, 2, 3, 4, 5, 6. So the parent chain has 6 carbons, therefore it is hex. And instead of "ane", I need to use "ene", so this is hexene. Then I need to find the substituent, name them, and number the parent chain. So the substituent are 2 methyl groups, and I need to number the parent chain. So the best numbering pattern would be from right to left because it gives the lowest number possible to the first substituent. So let's write the name of all the substituent. I have a methyl group on carbon 2, so it is 2-methyl. And I have a methyl group on carbon 4, so it is 4-methyl. Since I have same substituent, I can combine them to one another. So it's going to be 2, 4. I separate the numbers with comma. Dash to separate the letters. I have 2 methyls. It's going to be dimethyl. If I had 3 methyls, it should be trimethyl. Now let's put the name of the substituent before the name of the parent chain. So it's going to be 2,4-dimethyl. Now, here is the rule for alkene and alkyne. I also need to define the location of the double bond. And the double bond starts at carbon 2. So I put a dash, 2 dash hexane. So these 2 shows that the double bond should be started at carbon 2, and it should be between carbon 2 and carbon 3. Now let's look at the next structure. So first, let's identify the functional groups presented in the molecule. I can identify alcohol and a ketone. So if I look at the table, ketone is preferred over alcohol. Therefore, the parent chain should get the suffix "on" instead of "ol". Now, so my parent chain here is cyclic. It is cyclopentane. Because it is a ketone, I need to write that as cyclopentanone. It gets the suffix "on". Then let's number the parent chain. So I start with the priority functional group 2, 3, 4, and 5. So I have a hydroxy substituent on carbon 2. Therefore, this is 2-hydroxy cyclopentanone. Now for the third structure, again, we need to identify the functional groups. So I can recognize alkyl halide and acid. So obviously looking at the table, carboxylic acid is the first priority. Therefore, my parent chain should get the suffix oic acid. And the parent chain is the longest chain possible. So this is 1, 2, 3, 4. So it has 4 carbons. Therefore, it gets the prefix but and the suffix oic acid. So it's going to be butanoic acid. Then I need to number the parent chain. So the priority gets number 1, 2, 3, 4. It's going to be 2 dash bromo butanoic acid.